They promised locomotives strong enough to rule American railroads for decades, built with bold ideas and sleek designs that looked perfect on paper. But once they hit real tracks with heavy trains, problems started fast. The 1950s became a graveyard for 10 machines that failed in costly ways. EMD dominated the diesel locomotive market by the late 1940s, and their F-unit cab locomotives were selling faster than the factory could build them. But the F-units had a problem that railroad crews complained about constantly. Engineers could barely see behind them when backing up, which made switching operations on branch lines dangerous and slow. EMD's answer was the BL2, a locomotive that tried to split the difference between a streamlined cab unit and a practical yard switcher. The design started with a single prototype called the BL1, which was basically an F3 with a cutaway body behind the cab, so engineers could actually see where they were going. Railroads tested it, gave feedback, and EMD refined the concept into the production BL2 with a heavier frame and the ability to operate with other locomotives in multiple unit consists. The BL2 looked like nothing else on the rails. Its unique semi-streamlined body earned it the nickname Bulldog, and the design blended the polished look of a passenger locomotive with the working features of a branch line hauler. Footboards on the front and rear pilots let switchmen ride outside the unit safely. An optional steam generator meant the locomotive could heat passenger cars. The whole package was supposed to handle the light traffic branch lines that made up roughly 80% of the American rail network. The locomotive packed EMD's 567B diesel engine under the hood, producing 1,500 horsepower through 4-traction motors. It weighed 230,000 pounds, ran on a BB wheel arrangement with Blomberg trucks, and could reach 65 miles per hour. On paper, the specifications looked competitive for secondary line service. But the BL2's elegant body created problems that outweighed its advantages. The complex car body structure made it nearly impossible for maintenance crews to access the engine and generator without pulling the locomotive apart. The design lacked the full-length exterior walkways that brakemen and switchmen needed to move across the unit during operations, creating safety hazards that frustrated every railroad that bought one. The locomotive inherited the worst traits of both cab units and hood units without fully delivering the benefits of either. That's just the beginning. Subscribe now so you don't miss the rest of these ambitious failures. Only 58 units sold across 9 railroads between February 1948 and May 1949, with the Chesapeake and Ohio taking the largest order at 14 units. The entire production run lasted barely 15 months before EMD pulled the plug. The BL2 was a commercial disaster by every measure. The failure that taught EMD exactly what not to do. Every problem with the BL2 became a solution in the GP7, which arrived in 1949 with an offset cab, a short hood, full exterior walkways, and a utilitarian layout that mechanics actually wanted to work on. The GP7 became one of the best-selling locomotives in history, and it existed because the BL2 showed EMD how badly a good idea could go wrong. At least 7 BL2s survive in museums and tourist railroads today, including Western Maryland No. 82, running in its original fireball paint scheme on the Durbin and Greenbrier Valley Railroad. EMD learned from the BL2 fast enough to save itself, but the next builder on this list tried to bring submarine technology to the railroad and discovered that what works underwater doesn't always work on land. Fairbanks Morse built engines for submarines during World War II, and the company figured that technology could conquer the railroad market. Their trainmaster arrived in April 1953 with 2,400 horsepower packed into a single unit, making it the most powerful single-engine diesel locomotive on the planet at the time of its debut. That power came from an opposed piston engine where 2 pistons per cylinder moved toward each other, a design that worked beautifully underwater but turned out to be a nightmare on rails. The trainmaster looked imposing at 66 feet long and 375,000 pounds, riding on 6-axle trucks that gave it enormous pulling power. Starting tractive effort reached up to 115,000 pounds depending on the gearing, and the locomotive could handle heavy freight, passenger trains, and switching duties with equal authority. Fairbanks Morse toured demonstrator units across the country to show railroads what all that power could do. The demonstrations impressed buyers enough to generate orders, But the problem started the moment railroads put train masters into regular service. The opposed piston engine was incredibly sensitive to impurities in fuel and lubricants, causing piston seizures and breakdowns that left locomotives stranded on main lines. Vibration from the unusual engine design fatigued components and rattled crews through entire shifts. Most railroad mechanics had never seen anything like the opposed piston layout, which meant maintenance took longer, cost more, and required specialized training that most shops simply couldn't provide. Fairbanks Morse built 105 domestic units and 20 for Canadian Pacific over 4 years, a fraction of what EMD sold in GP9s during the same period. The Pennsylvania Railroad scrapped its train masters after barely a decade of use. The company exited the locomotive business entirely in 1958, and the train master's reputation for unreliability was a major reason why. Several train masters survive in preservation, including Southern Pacific No. 3021 running at the Niles Canyon Railway in California. The trainmaster proved that raw horsepower meant nothing if mechanics couldn't keep the engine running. And the next entry on the list learned the same lesson with an engine that smoked so badly it became a running joke across the entire railroad industry. The American Locomotive Company needed a diesel that could compete with EMD's dominant F units in the freight market, and the FA-FB series was supposed to be that locomotive. Introduced in January 1946, these covered wagon cab units used Alco's new 244 diesel engine and came in cab and cabless booster configurations that railroads could combine into powerful multi-unit consists. Alco produced roughly 1,401 units across all variants, selling to major railroads including the New York Central, Union Pacific, and Santa Fe. The numbers looked respectable until you compared them to the thousands of F units that EMD was shipping from LaGrange, Illinois. The 244 engine was the source of nearly every problem the FA-FB encountered. Early crankshafts failed because they were cast instead of forged. Exhaust manifolds cracked under normal operating temperatures. Turbochargers overheated or lagged behind throttle inputs, creating massive plumes of black smoke that became the signature Alco smoke rail fans still talk about today. Traction motors overheated and grounded out, generators failed without warning, and control systems glitched in ways that stranded trains miles from the nearest shop. While later versions of the 244 engine improved, the damage to Alco's reputation was already done and buyers had long memories. The Alco-GE partnership that supplied electrical components dissolved in 1953, cutting off support at exactly the wrong time. Most FA-FB units were retired by the 1960s and 1970s, and the series became a cautionary tale about rushing an unproven engine into production. Alco at least managed to sell over 1,000 units before the problems caught up with them, but the next builder on this list created something so massive and so complicated that only 3 railroads in the entire world were willing to take a chance on it. Baldwin Locomotive Works had built steam engines for a century, and the company's entry into the diesel market reflected that background in the most extreme way possible. The Centipede packed 2 3,000 horsepower diesel engines into a single frame, delivering a combined 6,000 horsepower through a 2D D2 wheel arrangement with 12 axles, 8 of them powered. That nickname came from all those wheels looking like legs crawling down the track. At 91 feet long and nearly 600,000 pounds, the Centipede could generate 205,000 pounds of starting tractive effort and reach 93 miles per hour in passenger configuration. The Pennsylvania Railroad ordered 24 of them for hauling heavy trains over mountain grades, and the Seaboard Airline took 14 for passenger service. The National Railways of Mexico rounded out the customer list with 16 units. Baldwin built 54 units at roughly $500,000 each, and nearly all of them became maintenance nightmares from day one. The twin 608 NA engines suffered constant piston and crankshaft failures that kept locomotives in the shop more than on the road. The cooling system overheated under sustained loads during the exact kind of heavy service the Centipede was designed to handle. Electrical problems knocked out traction motors with depressing regularity, and the crowded internals made every repair job take twice as long as it should have. The Pennsylvania Railroad retired its entire fleet by 1963 after just 15 years of service. The The Seaboard gave up even earlier, pulling its centipedes by 1958. Every single centipede was scrapped by the mid-1960s, and not one example survives in preservation today, making them ghosts that exist only in photographs and scale models. Baldwin proved that cramming maximum power into a single frame created more problems than it solved. And the next company on this list entered the diesel market so late that it barely had time to fail before disappearing entirely. Lima Locomotive Works had been building legendary steam engines since 1869, including the famous Berkshire type that revolutionized freight hauling. When diesel power made steam obsolete, Lima merged with General Machinery Corporation of Hamilton, Ohio in 1947 and tried to reinvent itself as a diesel builder with less than 3 years to prove the concept could work. The first Lima Hamilton diesel rolled out of the factory on May 12, 1949, exactly 1 day before Lima completed its final steam locomotive. The company offered switchers and transfer units ranging from 750 to 2,500 horsepower, with the ambitious LT 2500 center cab transfer unit representing the boldest design in the lineup. 22 of those big transfer units went to the Pennsylvania Railroad for heavy yard work. Hamilton's engines actually performed reliably in yard service, earning praise from mechanics who found them durable and straightforward compared to some competitors. The problem was everything surrounding the engines themselves. Lima entered the diesel market at least 5 years too late, competing against EMD's massive dealer network and parts inventory with a tiny catalog and limited production capacity. Only 174 units left the Lima factory over barely 2 years of production, a number so small that it couldn't sustain a locomotive manufacturing operation. The merger with Baldwin on November 30th, 1950, sealed the company's fate forever. Baldwin Lima Hamilton shifted the Lima plant toward construction equipment instead of locomotives, chasing highway contracts instead of railroad orders. The factory changed hands multiple times before closing in 1980 and being demolished in 1997. A handful of Lima Hamilton diesels survive, including Cincinnati Union Terminal LS 750 number 25, running excursions on the Whitewater Valley Railroad in Indiana. Lima Hamilton showed that even a reliable engine couldn't save a company that arrived too late to a market already controlled by bigger players. And the next entry proves that Fairbanks Morse didn't learn from the Trainmaster's failures when they kept pushing the same troubled engine design into smaller locomotives. Fairbanks Morse didn't give up on opposed piston technology after the Trainmaster struggles, and the company continued pushing the same engine concept through a family of road switchers and yard switchers that included the H1644, H1244, H2044, and H1544 throughout the 1950s. The H1644 offered 1,600 horsepower from an 8-cylinder version of the same opposed piston engine. And Fairbanks Morse built 299 domestic units between 1950 and 1963 for railroads including the New York Central, Santa Fe, and Union Pacific. The H2044 pushed to 2,000 horsepower on 4 axles, which made it so prone to wheel slip that engineers had to nurse the throttle constantly to keep drivers from spinning uselessly against the rail. Every model in the lineup shared the same fundamental weakness that had plagued the Trainmaster. The opposed piston engines demanded precise lubrication, choked on fuel impurities, vibrated components into early failure, and required maintenance procedures that most railroad shops had never encountered before. Railroads that bought Fairbanks Morse units found themselves training mechanics on a completely different type of engine, while EMD customers simply followed the standard procedures they already knew by heart. Odd characteristics like delayed throttle response, unfamiliar exhaust sounds, and handling quirks that differed from every other locomotive on the roster made crews reluctant to operate the units. Sales across the entire mid-1950s lineup remained modest compared to what EMD and Alco were moving, and Fairbanks Morse exited the locomotive business in 1958 after accumulating losses that the company couldn't sustain. The H1644 outlasted its siblings in production, but couldn't overcome the reputation that the opposed piston engine had earned across the industry. Fairbanks Morse kept betting on the same engine technology until the company ran out of money to lose, and the next entry shows what happened when the market leader tried something genuinely new and discovered that even EMD could stumble when pushing into unfamiliar territory. EMD had dominated the diesel market with naturally aspirated engines for over a decade when the company decided to enter the horsepower race with the SD24 in July 1958. The locomotive bolted a turbocharger onto the proven 567 engine block to squeeze out 2,400 horsepower, making it the first turbocharged production locomotive in EMD's history and a gamble on technology the company had never shipped to customers before. The six-axle SD24 weighed roughly 365,000 pounds and delivered starting tractive effort near 100,000 pounds, targeting heavy drag freight and helper service in mountainous territory. Union Pacific became the largest buyer with 105 units, including all 45 cabless booster versions, followed by the Santa Fe with 80 units that would later need complete rebuilds. The turbocharger system was SD24's greatest innovation and its biggest headache at the same time. The turbo clutch wore out from constant engagement cycles under varying loads throughout normal operations. Bearings failed when oil pressure dropped during throttle changes that happened dozens of times per shift. The forced induction strained the 567 engine block beyond what its naturally aspirated design had been built to handle, creating reliability problems that older EMD locomotives never experienced in years of hard service. EMD built only 224 units over 5 years, a modest number that reflected railroads treating the SD24 as an experiment rather than a proven workhorse they could depend on. Santa Fe eventually rebuilt all 80 of its SD24s into SD26s with newer 645 engines, essentially admitting that the original power plant couldn't deliver what the design had promised. The SD24 proved that turbocharging worked in principle, and that proof eventually led to the dominant SD40 and SD45 series that became the backbone of American freight railroading for decades. EMD stumbled with the SD24, but recovered because the company had the resources and the market share to survive a failed experiment. And the next entry shows how a complete newcomer managed to turn early growing pains into a dynasty that would eventually dethrone EMD itself. General Electric had supplied electrical components to Alco for decades, but the partnership dissolved in 1953, and GE spent the rest of the decade developing its own locomotive from scratch with the goal of breaking EMD's stranglehold on the American market. The U-25B that emerged in 1960 packed 2,500 horsepower into a 4-axle frame, making it the most powerful road locomotive of its size available anywhere in America. GE built a new engine for the project called the 7F DL16, a 16-cylinder 4-stroke diesel designed for durability and parts commonality with industrial applications that GE already manufactured. The locomotive featured a pressurized car body that filtered air before it reached the engine compartment, reducing contamination and extending component life in ways that competitors had not yet matched in production locomotives. Early U-25Bs suffered the expected teething problems of any first-generation design from a company that had never built a complete locomotive before. Turbocharger lag frustrated engineers during acceleration when they needed the power the most. Oil leaks required constant attention from maintenance crews already stretched thin across busy shops. Crews complained about uncomfortable cabs with poor control layouts and slippery steps that became hazardous in wet or icy conditions. The wheel slip control system was primitive compared to what later models would offer, and adhesion problems showed up on grades where railroads needed every pound of tractive effort the specifications had promised. GE responded aggressively to every complaint by sending engineers to railroad shops with extended warranties and rapid fixes that built trust with customers who were used to EMD's dominance and expected the same level of support from any competitor. The company produced 478 units between 1960 and 1966, a strong debut that cracked open a market EMD had controlled for 2 decades and proved that a well-funded newcomer could compete at the highest level. The U-25B's early struggles and eventual success launched the Universal Series that made GE the largest locomotive manufacturer in North America by the end of the century. GE proved that a new player could survive early failures and come back stronger. But the next entry takes us back in time to a railroad that poured everything it had into steam power, just as diesel was about to make every steam locomotive in America obsolete. The Pennsylvania Railroad poured its engineering ambitions into the duplex drive concept, building steam locomotives with 2 sets of cylinders, driving separate groups of wheels on a rigid frame. The idea was to generate more power with less hammer blow on the tracks, and the PRR commissioned some of the most visually striking locomotives ever built to prove the concept could work at speeds that would embarrass the competition. The experimental S1, a massive 6446 designed by industrial designer Raymond Loewy, debuted at the 1939 World's Fair with Art Deco styling that made it look like it was doing 100 miles per hour standing still. The production T1 followed with 50 units built between 1945 and 1946, generating up to 7,000 horsepower with 80-inch driving wheels designed for high-speed passenger service on the PRR's premium routes. The T1 earned a reputation that no railroad wanted to advertise to the traveling public. Crews called it slippery because the rigid frame and unsynchronized drivers lost traction at the worst possible moments, spinning wheels on wet rail and damaging tracks during startup when passengers were already seated and waiting to depart. The Franklin rotary cam poppet valves that controlled steam flow were brilliant in theory, but nearly impossible to maintain in practice, requiring specialized knowledge that the PRR never adequately trained its shop forces to handle even after years of operation. The single S1 was scrapped in 1949 after its enormous size restricted it to straight track and limited its usefulness across the railroad's network. All 50 T1s were withdrawn between 1952 and 1953 and scrapped by 1956, victims of both their own mechanical problems and the diesel locomotives that could do the same work without the headaches that had haunted the duplex concept from the beginning. No original duplexes survive today, though the T1 Trust Organization is currently building a new T1 number 5550 from original blueprints with a target completion date around 2030. The Pennsylvania Railroad spent a fortune trying to perfect steam power in its final years, and the last entry on this list shows what happened when General Motors tried to save passenger railroading by building a train that looked like a car and rode like a bus. General Motors looked at declining railroad passenger numbers in the 1950s and decided the solution was a train that looked like a car. The Aero train combined a low-slung diesel locomotive with coaches built from modified GM bus bodies, creating a futuristic train set that promised 100-mile-per-hour speeds, a smooth ride from air cushion suspension, and operating costs low enough to make passenger service profitable again for railroads that were bleeding money on every ticket sold. GM built 2 prototype train sets and sent them on demonstration tours across major railroads, including the Pennsylvania, New York Central, Union Pacific, and Santa Fe. The trains look spectacular in publicity photographs, with their rounded automotive noses and wide window coaches sitting lower on the rails than anything else in service at the time. Revenue Service exposed every flaw the demonstrations had tried to hide from railroad executives. The air suspension bellows that were supposed to deliver a floating ride failed above 60 miles per hour, turning the coaches into bouncing boxes that injured passengers and generated complaints from everyone who rode them for more than a few minutes. The bus-derived bodies were too narrow and too rigid for railroad dynamics, amplifying every rail joint into a jarring impact that no amount of engineering could fix without starting over from scratch. The 1,200 horsepower locomotive struggled on any grade steeper than flat ground, sometimes requiring helper engines to maintain schedules that the marketing materials had promised it could handle alone. No railroad placed an order after the demonstrations ended, and GM sold both train sets to the Rock Island Railroad at bargain prices for Chicago commuter service, where they rattled along until retirement in 1966. Both Aero trains survive today as museum pieces, with train set number 1 at the National Railroad Museum in Green Bay, Wisconsin, and train set number 2 at the Museum of Transportation in St. Louis, Missouri, standing as monuments to what happens when automotive thinking meets railroad reality. 10 ambitious designs and 10 expensive lessons from a decade that reshaped American railroading forever. The 1950s punished companies that chose raw power over reliability, style over substance, and innovation over proven engineering that mechanics could actually maintain. Do us a favor and hit that like button and subscribe for more stories about the machines that changed everything and the ones that never got the chance.